manufacturing technology course and BTech, MTech, and we are not here to discuss. But what I want to say is the why we want mechatronic become modern machine. I told you CNC machine. CNC machine is a mechanical structure. This mechanical structure will be designed by a mechanical engineer. Then it has electric motor, control circuit, all those things. Then you need an electronic engineer who is going to design the power electronic circuit, motor design, electrical engineer. Then you need a computer and you have to write program. Correct? Simple G code you can write. With advanced control algorithm is you need a computer science engineer who can write the program, who knows write the program quickly, better way, algorithm, all the thing. But the algorithm will be designed by you, that will be implemented. So you need different type of engineers when you want to make new generation machine which are fully automatic. That's what we want to do. The course is about how to design a automatic machine. Correct? What are the individual components? Correct? What are type? It uses sensors, it uses actuators, it uses control algorithms, it uses control electronics like ECU, all those things, apart from mechanical design. We are going to see all those things in this course. So then, as I told yesterday, the mechatronic is combination of two words. One is called mechanism and electronics. This word was coined by the Japanese engineer who was working in Escova Electric, correct? His name is Tetsuro Mori. He coined this word 1969 when he was working this one. He said, I will design electronic circuit, integrate computer software to control a mechanical. Basically, that time a computer was in the beginning stage. They were using electronic circuit to automate machine. Programming was very limited because that time 1970s and the computer very big, bulky, expensive. But CNC machine, all those things can be automated without using computer, just using electronic sensors and controlled algorithms in part of what you call analog computer. Correct? Analog computer. We are going to see analog computer can be built using op-amps. Op-amp is electronic circuit which is called IC, integrated circuit. Using this, you can build computer which can do addition of two signals, electrical signal, not numbers. Correct? We are talking signal coming from two sensors or this one. And then it can subtract two signal, electrical signal, multiply, divide. All the operation can be implemented using op-amps, which is called an analog computer. Analog computer there for last more than 80 years, even before this one. So that is even now used all. If you see Soviet Union, India has imported a lot of fighter planes. MiG, correct? MiG fighter plane, we are extensively using 21, 24, 25, 29, 30. Now we are also collaborated on MiG-30, correct? MKI, they call it. MKI. This is with collaboration this Russian company and HAL jointly they made 250 planes, 300 planes for Indian Air Force and this Navy and all. Correct? So these planes are using modern digital computer. Correct? There are two types of computer. What we are seeing computer is called digital. Correct name is called digital computer, which uses microprocessor, memory, all those things, and they work on using what binary numbers, all these things. But analog computers is built using op-amp. These computers are used in many of the MiG fighter planes still in use in India. Correct? MiG-29, all these things still they are using analog computer developed this one. They are advantage compared to digital computer. Similarly, digital computer has another more advantages compared to analog, but there are some data we will see when we talk about control system. So now your analog, the mechatronic system, the control can be implemented using op-amps, that is analog computers or digital computer. Correct? Digital computer, that is called model computer, what we are talking. Correct? You can use. Old generation automation use analog, even the advanced fighter plane, all this thing, present they just using digital computer. So then yesterday we did talk, I just want to start this by the time up. This was the third slide which I started because we started late. Nothing to worry, we can cover up all those things in one more extra class. So when we talk about product design, we are later going to see what we call as mechatronic product design. Correct? Mechatronic product design, and this is recent in last 10 to 20 years where you have more electronic, more automation in your machine. If you have more automation, more this one, you can use the mechatronic product design. Otherwise, previously we were using what you called as general or conventional mechanical product development. They are for last maybe 500 years, 1,000 years. Whenever machine was made, this what followed. What you do in convention before invention of computers, correct? And use of computer for designing mechanical parts. Before, I know that I'm repeatedly talking with the mechatronics computer use. You have CAD, correct? If you want to make a bolt or nut or any individual part, use AutoCAD to generate what you call a CAD drawing, correct? Drawing, you develop, draw it using computer, using a software. You don't need pencil, you don't need paper, you don't need a drawing board and mini draft, all this thing. What you need is just a computer. You sit inside, computer can be very compact. Then only you need a display and input a mouse, all those things. Type program using AutoCAD, you can generate the part, correct? For example, I want to generate a bolt, correct? So it has this one. This is cross-sectional view. This has a length L, correct? Then this is the bolt thickness. I can say T, correct? This is the bolt head. It can be hexagonal head, correct? That means it has different phases. This, if you want to make what you do, some 50 years before, correct? We have M5, M10, M20, M30 like that. You decide. So that means the T is fixed, correct? This length is the L is fixed, correct? For the particular number, if you say the M10 with this one, then the pitch of the this one thread, correct? The pitch is fixed, M10, M12 like that. Then head size, what should be? All these things are already fixed. For this, if you want to make it, first thing is you will make a drawing, correct? You will make a drawing. Product, this is called product design. This is, I am talking conventional design, which is followed for last 300, 500, 1,000 years, correct? Before you want to make even a simple component, a bolt, you need to draw and you have to give dimension. This is, for example, 20 mm. This may be 10 mm, or this can be 30 mm. Then this size can be, you can say that this diameter face to face. This can be, for example, 30 mm, correct? Or 15 mm. I can say the 15 mm, correct? So all these things are drawn, and you say the what is thread type, what is pitch. All these things you draw, make a drawing sheet on which you mentioned all the dimension. That is called the product design. Then the bolt can be made with different material. You can make aluminum, you can use brass, you can use cast iron or stainless steel, any material. That depends upon how much the force, correct, or torque it has to insert before shearing. When I wanted to connect two parts, you are going to tighten with another nut. There are two parts and which are to be this one, you tighten it. That time, how much torque it has to force, correct, when you joining, which are that depends upon the material use, the dimension, correct, the bolt dimension, all these things. So that means shape of the material use, whether using aluminum, correct, what type of process you use, correct. But that means first thing is you are not good. You are getting the solid rod, correct. You want this should be 15 mm, this should be 10 mm, correct. That means at least 20 mm rod should be, solid rod should be taken. This is called workpiece, correct. So you would have taken this is 30 mm, means maybe 35 mm or 30, at least 35 mm, this length, correct. This is 20 mm. This you put it in the machine, for example, lathe, and first to make the rough cut, fine cut, then you may reduce the size because leave this gap, then you do a step cut, correct, step cut, then you remove this material, something like this parts are removed, then you get this using a lathe. After that, you have to do a threading. You may use same lathe or some other tool or machine, correct. So you remove the part, put in another machine, do different process and different machines, correct. Create the individual this one. So if you take a IC engine, you need to make a piston, you have to make a connecting rod, you may do a crankshaft, you may have to valves, correct. Then a cylinder head, cylinder, crankcase. There may be another 20, 30 parts in the engine. All those things will be product design. Before making, first you make a drawing, then select what material, what shape it should be. All the drawing shows the shape, size, individual part, dimension of the material, and material design, all those things. So design is over. So once the drawing is made, this drawing is given to the shop floor. To generate the part, you give it to the shop floor, where the, as I told them, take the raw material, use different machines, correct? Generating parts using the assembly drawing, correct? So assembly drawing or product drawing. After that, the prototype, once the component is made, you assemble the component, you assemble your engine. Then you test. The testing can be done individually. For example, as I told you, engine consists of piston, cylinder, connecting rod, gudgeon pin, crankshaft, correct? Camshaft, valve springs, bolts, nuts, correct? All those things you make, and each component can be tested individually. What if suppose by how you use a different machine, testing machine, universal testing machine, which can apply compressive force, tensile force, and see whether the bolt can withstand that this one force. When it shear happens, where is the weak spot? All this thing you will do by testing in the actual. First you make the drawing, after that make the component, test it on the testing machine. And if it is not working, what you do? Again you go back, product design. What you do? Change the material. You made with aluminum, it is not working. What do you do? You use MS or stainless steel, correct? For the same dimension. Like that, you do that iterative process. You come like this. When everything is okay, that's what I call redesigning. This step is called as redesigning. What do you do? And the redesigning, you test it. If fails, the component fails, then you redesign. Redesign going back here, correct? Changing material, changing shape, under different process, correct? The finishing is not coming properly. All those things may change it. Instead of grinding, you may use a buffing, something like that. You do all those things. Then do the again part. Further again make a drawing. This is repeated process. This is then everything is okay. Prototype testing, everything is success. Correct? In this case, it is a success. You come to product. Then you make a large quantity, more machine. The drawing, everything is already not tested, all these things. Then make product and launch the product and sell it. This is how the mechanical products were made for last thousands of years. That means make a drawing, make the individual component, test them, and assemble the component, test the sub-assembly, make the complete car, test it on road, track, suspension, power, all these things in your test track of your company. If everything works, then only run. The whole thing is called a product life cycle. You all know, I need not tell. Product life cycle. Product life cycle, if you want to make a new, for example, car, a new aircraft, or new CNC machine, anything, depending on a component complexity, it can go for 6 months or 1 month to even 10 years previous day. Because what you do? First time you made the bolt using this aluminum to made a drawing, all this thing. For example, it took, say, for example, 2 days, and you tested, it failed. Correct? It is not able to withstand the force what you apply, tightening. So immediately you can redesign. Instead of 10 mm diameter, this one, this you can make it to 12 mm. But whether it is allowed or not, we don't know. Suppose they say the diameter of the bolt cannot change beyond 10 mm. Okay, fixed. Then you cannot use aluminum. Maintain means you go for SS, stainless steel. Correct? So different operation, then test it. If it is success, then you say that instead of this, the product. So this product cycle takes huge amount of time, correct? Huge amount of human manpower, correct? Machine timing, and also cost. Physically, you have to make, this is called physical prototyping. In conventional product design, before invention of the AutoCAD software, FE analysis, we have what we call simulation, modeling and simulation. That's what I wanted to come. The mechatronic design means first you won't make the product directly, like this one. You don't even make drawing using the modern computer style. Use your AutoCAD to make the drawing, correct? Then you use the drawing. AutoCAD drawing can be 3D modeling. You can do. You can virtual machining. It is called virtual prototyping. Physical prototyping was used in this one, old design, correct? For thousands of years, correct? Even now they are using small factory, all those things. But it is a time consuming, correct? Money is wasted, material is wasted, correct? To make one product, the product cycle can, depending on complexity, 6 months to even 10 years. For example, new aircraft, correct? You know that 737 aircraft, correct? A320. I'm giving recent example. The most complex, I will say A380. Many of you know it can carry up to 800 passengers. The Airbus made, correct? This to make such a machine which can carry, which is 747 can carry up to 400 people. It was designed some 50 years before. Now they stopped the production. They sold around 5,000 or 10,000 aircraft. I don't know. Correct? Each aircraft millions of dollars that can carry. To compete with them, Airbus started making new machine because Airbus has 320, A320, 340, 350. 350 is slightly smaller than 747. Correct? So which are four jet in all this, and they are competitors. But the Airbus wanted to compete so big machine which Boeing did not have. Correct? When it one from Asia to US, more people can carry in single aircraft, fuel efficiency, all this thing happen. So what they did, Airbus started designing A380 which can carry 800 people. You know, they said the product from the drawing board. First thing is you get an idea how many engines, all the what shape, all this thing. Of course, as aircraft they know it. Then product design, make the drawings, each and every component, and using AutoCAD, all these things. If the world is this one, from this, the testing of this one, they said 10 years. That's what they predict. Because I don't know exact number. I generally watch in internet all those things. I'm literally interested in knowing aircraft, all those things, personal interest. So I see. They say they predicted make 10 years to make such a big machine because nobody has made. Correct? But they're able to complete it in 6 to 7 years. The product came out within 8 years, actual product for testing. How it happened? They were using what you call as mechatronic way of designing. Mechatronic way of design only next step. Okay. So just please note that again, one more thing. I will not share any of the slides. I'm not going to share any of the slides. You have to take notes. The new batch student, sir, exam is coming. I want PPT. No, PPT can a lot of information which I took from all those things. I cannot share it. Copyright. So there are many issues are there. So I will not be able to share. Please take notes. Take the important, because I am giving bullet point. Apart from I am explaining, you have to take your notes. Correct? For example, in exam, the quiz is coming or midsum exam. So explain what is the conventional mechanical product development steps involved. Give the steps and briefly explain each step. Correct? Then don't write the steps. Sir, in your slide, you showed only 7 bulleted points. This is what you showed. So I give 3 marks. You write 7 points. What is shown in slide, and as per 3 marks, I will give only half mark or 1 mark. You have steps only. Each one I am explaining what it is. You have to take a notes. I will not share any PPT. This is how I am teaching for the last 23 years. Even in my class, regular class, I never share PPT. You have to sit, listen, and take notes. Correct? You just log in and just to do whatever you want to do. I am not going to watch you what you are doing. Correct? After exam, after 15 class, please give me PPT, sir. No, I am not going to provide. You have to take notes because I am systematically teaching, spending every day 1 hour. Before class, I am revising because this course I am teaching for at least 20 years, correct? Continuously. And even now I am updating my PPT notes, all those things. You have to take notes. I am not going to give. This is being first. I am very clear. Exam, I missed another. You have to talk with the other students. That's what you do in this one. You talk to your classmates. Sir, I am in some other faculty. Talk to him. You would have take a note. Ask him to share notes. I cannot give the PPT. I am very clear about it. Why we are asking? If you write, I am not just blindly saying. Because I also did my B.Tech, M.Tech, PhD. I attended. Not going to help you. That's why we are saying that you have to take notes. This is my policy. I don't. Then don't say that other professors are giving all those things. That is not my concern. I am teaching this course. This is how I teach. This is how this one. But I am giving. I am not changing slides. per lecture, some 100 slides, 50 slides, sir, I cannot take notes. You saw that? I show these slides, at least I'm teaching for 5 minutes. Within that, you can write. If you are not ready to do that, that is not my problem, it's your problem. I will not share notes, video, nothing. You have to sit and take. Your company allowed you to sit in the class. If you miss one class due to not well, all this thing, you are just one. You talk to your student, your other students, get notes and read. Nothing more than I can do. Okay, so this is called as the conventional design. This is what we have done. What is the drawbacks I told you? Correct. Development time is high. Correct. Materials are wasted. Then human resource or human energy also wasted. Because you are every time you have to draw your same thing, but that's the only way. Correct? Wasted. Correct? Then cost of the development become enormous. Because you make first board doesn't work. You take a spring. You want to make a spring, you take a spring material wire. Correct? You want to do the spring stiffness measure so much, say for like 100. Correct? 100 unit, but this one. Now you how will you make? You take a wire, spring steel wire having, for example, generally be a solid wire, maybe 5 mm thickness. Correct? And you make as a coil. Took a wire and made it a coil. This is called springing. Correct? This is spring material. Then how will you know that whether the K is the stiffness? How will you find out? You apply, put it on the machine. Correct? Where one end is fixed, other end you apply a load, force. Correct? As you force, originally the spring had a length L. Correct? Say for example, this is for example 5 centimeter. Correct? And when you apply the load, the length reduces 4.5. Zero force, I applied 1 Newton force, 2 Newton force, like that. Then I draw a graph, 0 to 10 Newton. Then this is originally 10 centimeter, it become 9, 8, 7, 5, like that, it stops. So if you connect, you get a line. Correct? Then if you connect it with this one, you can write an equation for line, straight line. Correct? Y equal to mx plus c. Correct? This is called model of the spring. Y equal to mx to this one, where the m is going to be decided by the spring material stiffness. The stiffness is decided by the thickness of the wire. If 2 mm, some way thick, this one, it will give some stiffness K. So what you do testing. Suppose it is not giving, I want 10 this one, I used the 5 mm thickness. This one, it was not giving 10, it give only 8. What I do, I take a wire which has 6 mm thickness, 7 mm. I cannot come down. Again, make a spring. This is how we're doing. As I told you, repeatedly you have to make, you are going to solve. So the cost of these are the drawbacks. But no other option, because this is the only way available for last 5,000 years, 2,000 years, when machines were made from the Greek period. Correct? Greeks also invented a lot of machines. Similarly, Egyptians. Correct? Many civilizations, Indian civilizations, Indus Valley civilizations. These people made some machine, whatever is possible of 5,000 years old. All these things were done like this only. Correct? Make a drawing, from that, make the individual component, assemble, test it. Chariot making, water making. This is drawback. So now, being nowadays you have computer, because of computer you have a lot of advantages. I think yesterday we talked about this. Arnasalam, anybody? Did we talk about definitions?
No, sir.
No, sir.
Not yet, sir.
Okay, fine. Now we know what is convention is. New this is called the mechanic. See, these machines as one thing is this one. Apart from that, there did not any electronic control software, nothing. Correct? That was not there during the time. Correct? Only last 30, 40 or 50 years, we have electronics and computers and sensors, actuators are used to make the machine fully automatic without human presence. We can do manual, semi-automatic, fully automatic, and autonomous. There are 4 levels of machines are there. We are going to see what all those things as we move forward. Okay, so this is called full conventional, full regular mechanical, full mechanic. For example, ambassador car is there, Fiat car is there, correct? Do you see anything in that, any electronics? Nothing, correct? Electrical, yes, you see electrical. What is the spark plug? Yeah, high tension coil, that is which generate the high voltage for spark. This one, headlamps, tail lamps, maybe a fuel pump to suck the fuel from the tank and to supply it to the carburetor or fuel. That time only carburetor. In diesel engine means mechanical injectors, correct? There's a pump which pressurizes the diesel fuel to 300 bar, 400 bar. They call unit injectors. No electronic, nothing, correct? Afterwards, the music system were installed, ambassador card, all those things. Even now you can see somewhere. I have traveled in it because when I was okay, this one, even now available. Fiat car, all those things. Maybe you have your tape recorder, they call it. That time you did not have computer, music system, pen drive, all those things. They were using what you call tape recorders, magnetic tape recorder, in which music will be recorded, new songs that you can hear. That is what the maximum electronics. If you have a tape recorder or a radio in your car, it is what you call luxury car. They call it luxury car. Just adding one electronic tape recorder, which costs 2,000 rupees. Car is 30, 40,000 rupees. That's ambassador car I'm talking. Correct? Later, the engines, you want to increase the fuel efficiency on the engine. So they, instead of carburetor, they introduce fuel injection system. Diesel will CRDI, petrol engine, GDI, and port fuel injection system. There, you use the computer, sensors, and actuated injectors, all those things which are controlled by software. So engine became electronically controlled. Then brakes, anti-lock braking system. Then say assisted, correct? Electric assisted, hydraulic assisted, electronics. Then traction control. Then air conditioners, even before temperature control, correct? Then traction control, modern autonomous control, autonomous vehicle, correct? Of course, the old batch already gone through the code, they know it. New batch next semester will be knowing, correct? Next coming semester, I am going to tell that time you know. Correct? So now the modern vehicle, even the automobile, starting with ambassador, Fiat, now we have hundreds of different varieties. Mahindra is making, Tata is making, Suzuki is, Maruti Suzuki is making. Correct? I'm talking Indian company. Correct? Big automobile manufacturers, they make different varieties of cars, starting from nano to luxury cars, costing 20 lakh, 30 lakhs, all those things. Of course, imported cars, BMW, all those things are also is there. They are starting factories in India. Correct? Hyundai Honda has a factory. Other companies also wanted to come and do manufacturing the product itself here. So those in these modern cars, you have a lot of electronics, lot of control system, and for that to run the program, you need computers, lot of sensor, all those things. We will see some of the examples now. Now, the course, since we were talking about mechatronic, I just wanted to what mechatronic means. Generally, when I say I want you to describe about engine, correct? Petrol engine, correct? So you did your course on petrol engine. I am just asking. For example, Balaji Rajkumar, can you say what is the petrol engine? Can you define it? What is definition? Definition means you will not draw entire engine drawing some 10 pages. They call essay, correct? Short description. I want define means you have to be able to show, write, or tell in 2 to 3 lines. They're called definitions. Within that, I should be able to understand what the machine will do, what the product will do, or anything, correct? Your concept you wanted to explain to somebody in short, briefly, that is what the definition. Definition cannot be 10 line, 20 line, 30 line. It should be 2 or 3 lines. So what is definition for mechatronics? There are different books are there. In the internet, you said this one. And the people, when you talk about, each people will give definition differently. I'm giving some 5 to 6 examples. There are hundreds of definitions about mechatronics. But finally, basically it is nothing but what this engineer, right? Tesoro Mori, he told mechanical system controlled by electronics. That's it. That is the definition. Now, for modern purpose, we are taught, because that time computer was not used to automate the machine. Right? He was working in a company which was making some mechanical machines. He want to automate, use electronics. The new machine called mechatronic machine. He used the electronic circuit to automate the mechanical. So that time computer was not there. Correct? Modern computer, microprocessor, all the embedded and all this thing was there. So, but now we are using more software, more computer. The definition is changing. Correct? Even mechatronics. So the first one definition I want to say, synergetic use of precision engineering control. Precision engineering, I am talking about mechanical engineering, correct? You want to make components as close as tolerance, correct? So I want to make a rod with 20 centimeter length and 2 centimeter dia. I will say that I draw this one. This is a drawing, correct? This is 20 centimeter length equal 20 centimeter, and the diameter is nothing but I said 2 centimeter, correct? That is 20 mm. This is 200 mm. This is what I do, correct? So this is cross sectional view, and then the side view, it will be a circle, nothing more than giving 20 diameter will be 20, correct? So now if I give this drawing to your machinist, will you agree? If as a mechanical engineer, do you agree this is sufficient?
No, sir.
Somebody can answer. If this drawing is correct, if you're given to say workshop, a fit, correct, who is going to make this?
No, sir, we have to give tolerances and all.
Yeah, we need to give tolerances because no human can make exact this 20 mm diameter. Whatever machine, super finish, ultra super finish, whatever you do, still there is a tolerance. You say 20 mm plus or minus 0.01%, or plus or minus 0.1%, or plus or minus 0.01%, depending upon what operation you are going to do, what machine you have, correct? So you first you do a rough cutting, as you told you, diameter maybe 22 mm, put it on a lathe and do the turning operation, reduce it to, for example, 20.5 mm. After that, you may use grinding tool, reduce it 20.1 mm. Then you may use a buffing tool, buff it, try to make a 0.01 mm or 0.1 or something. That's not possible, correct? Still you want to do means you want the electrochemical etching, which can remove micron level, correct? So use different process to make it. So that means modern this one, each and every component, if you want a perfect machine which is efficient, which doesn't waste energy, each and every component should be made precisionly. There should not friction. If you moving point of that, the surface super means the amount of energy wasted as a frictional losses can be reduced, correct? You wanted to, for example, you wanted to two parts mated, correct? There should not be a gap. Then you need a super finish, correct? In an engine, you have the piston moving inside the cylinder, correct? The gap between this one, you have the rings, correct? Metal rings. So the metal rings prevents the hot gases to leak inside the crankcase, correct? So you need ultra super finish when make the piston rings. Piston ring surface should be nanometer accuracy, correct? Why? That means that the gas cannot leak. Still, it should move freely, frictionless. You need ultra precision machining for the piston rings, not for the piston, correct? Piston finish can be 0.01%, correct? But the piston rings to 0.01%. That is what going to prevent the hot air, because the pressure inside the combustion of 80, 100, 200 bars after the combustion, that should not leak. If it leaks, what will happen? The energy will be wasted. The pressure will be reduced. Then the force pushing down for piston moving, that force is proportional to P, correct? The F, the piston, which is connected to crank, this one, then the torque. The torque will reduce if the hot air is leaked inside the crankcase to gap. So you want ultra finish. That's why I said precision mechanical engineering. Each and every component should be as close as to with the tolerance. Then, since we are using control system, you need to know control theory, PID control, fuzzy logic control, neural network, correct? Or like adaptive control, all these things. Definitely, I'm going to talk something about control system for 4 to 5 hours. The basic control system is a part of the course. You will understand what it is, correct? If you want more, you have to read further this one subject. Then you need computer science, because you are going to use a small computer. That computer called embedded computer or embedded controller. Embedded controller is nothing but a small computer. What is in there inside your computer? You have a CPU, correct? Then you have a memory. Then you have a display. Then you have a keyboard and mouse. And you have a hard disk, correct? So what is each job? CPU is going to do all the calculation. You write program, C, Python, Fortran, whatever language you write a program. What is program? Program is nothing but logical steps. Logical step to process the data. Which data? maybe from you are giving A equal 10, B equal to 20, C equal to A plus B, correct? D equal to A C multiplied by 10, constant. Like that you write a program. So this is called logical steps. That logical, we call a flow chart, correct? Logical steps are given as a flow chart to a programmer. Then he converts the flow chart into C program or Python program or Fortran program, depending on what compiler has requirement. So that program will be compiled, and the compiler generate what you call machine code. So if you go and see your laptop or desktop in your directory, right click on it. Some files will be OBJ, some file will be exe, correct? Some file will be DOC, correct? Exe means it is executable code. The short form is executable program. This is what going to be run by the CPU, correct? If you see AutoCAD directly, go inside, don't delete any file. Go to, if your computer has AutoCAD, inside it, AutoCAD something will be there. ACAD.exe will be there, correct? This is nothing executable program which will be run by the computer CPU, and your program will be stored in the memory and the hard disk, correct? When you execute the program, result will be displayed on this, correct? Keyboard you use for entering your program. All these things are for general purpose computer. In controlling machine also you have computer which is called embedded controller. I stop here because other professional building is already 5:55. Okay, see you tomorrow. But tomorrow I am going to send you a new link, correct? I am going to send you a new link to all of you by this one. I will be using that link for this one from tomorrow onwards. Again, it will be Zoom link. I will send you a new Zoom link. For my class alone, use that. For Professor Ashish Kumar Sen, use the link sent by the code office. Already you received. For my class, I am going to send you tomorrow Zoom link that you have to use for attending my class. Don't use the link from tomorrow onwards. You will receive. Suppose if you don't receive, call me. Note down my cell number 9444 952257. 9444952257, my cell number. Suppose I will be sending you to a Smile account. New batch already have the Smile account. 2024 batch.
Yes, sir. We have, sir.
Yes, we have.
You are receiving mails.
We have, sir. We have.
Yes.